Hi everyone, hope you all are keeping well. So today is the third session, that is part 3 of AWS Serverless implementation. Speaker for today's session is Amith Mendis. So over to Amith.
Thank you, Dilma. Today is the session 3 of AWS Serverless implementation, and in first 2 sessions we have discussed about how Lambda works and how to implement Lambda plus API gateway. And today we are going to discuss about how to save data, that means databases. And in databases, we will discuss about one of the main serverless database in AWS, which is DynamoDB. Let's look at what are the database offerings which given by AWS, and there are plenty of databases which provided by AWS. In relational databases, they are providing Amazon Aurora, Amazon RDS, and Amazon Redshift. In key value databases, we have Amazon DynamoDB, which is we are going to discuss about. And it's good for high traffic web apps, e-commerce systems, and gaming applications. And in memory caching, we have Memcached and Redis. And document DBs, they provide Amazon DocumentDB. For white columns, that means high-scale industrial apps for equipment maintenance, fleet management, and route optimization. These are the use cases we can use white column databases. They provide Amazon key spaces. For graph databases, they provide Neptune, time series, Amazon time stream. For ledgers, Amazon QLDB. Let's move to Amazon DynamoDB database. And when we see what's Amazon DynamoDB, it's a full managed proprietary NoSQL database service that supports key value and document data structures. That means it's fully managed by AWS, and it's a NoSQL database, and it supports key value and document data structures. Let's look at what are the features of DynamoDB. First one is it's NoSQL database. Therefore, you does not require fixed scheme like RDS databases, and it avoids joins, and because of that, it's very easy to scale. And it's serverless. That means it fully managed by AWS. Therefore, we don't have to worry about the infrastructure management of the database. And it's cloud. It's a service provided by AWS. Therefore, we don't need to do the installations or setup for DynamoDB. It's available to configure and use, and it's very fast. They claims that it has very low latency, like single-digit milliseconds. And if we use DEX, which is the accelerator for DynamoDB, it can reduce up to microseconds. And it's very cost effective, and it's flexible. And it has the model of pay for what you use. Therefore, we does not need to pay for hardware which is not using, and every time we use, only we will have to pay for that. And that means price will be based on the capacity you use and read-write units you use. And it's high scalable, and it can scale up and scale down based on the demand. And that's a huge advantage when it comes to a database, because then you don't have to reserve the resources which required for highest requirement, and it will be scaled up and down based on your demand. And it's fault tolerance. It automatically replicates data on multiple availability zones. And if you want, even you can enable the cross-regional replications. It will cost you, but it's also available if you want, and it's fault tolerance. And it's secure because security is managed by AWS. You don't have to think about the security of DynamoDB. And the key concept we want to discuss when we come into a database is the data types. DynamoDB has 3 main data types. First one is scalar types, the second one is set, and third one is document types. In scalar types, we have numbers, string. The size limit of a string is 400 KB, If it's a partition key, we have to restrict it to 2 kilobyte. And if it's a sort key, we will discuss about these keys in later stage, but I just wanted to mention it here because then you will have full data about data types. If it's a sort key, it's 1 kilobyte. We can't go beyond 1 kilobyte in a sort key. And it has binary data types, which can be compressed text, encrypted data, or images. And size limit of it is 400 kilobytes. Again, it has same restrictions for partition key and sort key, and Boolean and null values. When it comes to sets, it can be set of numbers, string, or binary values. You can't have duplicates, or it needs to be in same scalar type. That means you will not be able to use string, numbers, and binary values in a single set. And in document types, we have list. This is similar to JSON array, and it can go down up to 32 levels deep. And item size limit is again 400 kilobyte. And it has maps. It's similar to JSON object, and again 32 levels deep. You can create maps, and item level size is 400 kilobytes. Now let's discuss about consistency models in DynamoDB, because consistency is one of the key features we have to think about when it comes to a database. Let's think we have 3 write and read nodes in DynamoDB, and a user writes data into node 1. Normally what will happen is it will replicate, that means system DynamoDB itself will replicate node 1, 2 and 3 itself, but there can be a delay in replication. Let's think user 1 is writing into node 1, user 2 is reading data from node 3 at same time, in the same data at same time. Therefore, what can happen is user 2 will not get the latest update of the data. Still, user 1 is writing it. Therefore, he will not get the most updated data set, and he will rely on it. Therefore, we have to think about consistency models in DynamoDB and use it according to our requirements. In consistency models, we have 2 main consistency models. First one is eventual consistency. It is consistency across all the copies within 1 second. That means it will guarantee that consistency will happen within 1 second. But the issue here is within that 1 second, other user can read it. That means the whole data copy can be read by another user. That's the issue in eventual consistency. But we use it when we need the maximized read throughput for the user. We are using this, but we have to consider the consistency issue when it comes to eventual consistency. The second one is strong consistency. It will update all the copies of data before returning a result to user. That means if someone is writing data, it will wait till that all the copies, that means it reflects all the updated values in all the copies, and it will return the data. Therefore, it takes some time to make sure the consistency is there. Therefore, it has a delay when it comes to, that is, when it compares with the eventual consistency type. That's why we say that eventual consistency will use for maximum read throughput. When it comes to cost, we have eventual consistency is 50% cheaper than strong consistency model. This is a comparison between eventual consistency and strong consistency. When it comes to consistency, strong consistency is good. You always read the latest update. Performance wise, eventual consistency is good, and cost wise, again, eventual consistency is good. The only thing is, if you want the latest update all the time for your clients, then you have to go with strong consistency data, consistency model for your database. And now let's discuss about the indexes. in DynamoDB, this is one of the critical concepts in DynamoDB, because this is not similar to relational database. And in DynamoDB indexes, we have two types of indexes. That means first one is primary index and the second one is secondary index. Within secondary index, we have again two types: local secondary index and global secondary index. We will explain it later. And any index can be divided into two types. That means it can be a simple key or composite key, as we know in RDBS also. And now let's discuss about local secondary indexes. Here you can see, that means let's think this is a sample database of articles, and the primary key is created as will be a composite key from article ID and category. And we have title, content, use ID, username and timestamp. Here you can see use ID and username is also here, because this is not a relational database. You can add everything into a single table if you want. That's why we have put username and use ID into this table. And now you can see there's a primary key. But again, if you want to do another, that means here you can see you can get the article by article ID and category. If you want to sort it by timestamp, then you will have to create a local secondary index. I will explain why this is called a local secondary key, because when partition key is same as the primary key, that means here you can see the primary key is article ID, and in the second case, again the partition key for secondary local index is also the article ID. Therefore, it's a local secondary index. That means when you create a local secondary index, the index will happen within the table itself. You will not need another table to create that partition. Therefore, that's why we call it local secondary index. And this has to be done in table creation time. That means you can't do it later, because all the data will be now you have to create the local secondary index in table creation time. That means you will not be able to edit in later stage. You will have to decide what are the local secondary keys you are going to put when you create the table. And the third one is maximum number of local secondary indexes for a table is 5. That means you will not be able to put more than 5 local secondary indexes within a table. You will think why we need this local secondary index. Why we need this is when you query the data in DynamoDB, you need to have an index. That means if you don't have any index, let's think if you don't have an index for use ID and you want to query this by use ID, then you will not be able to do it. You have to scan it. Scanning is costly. That means it's very costly. Therefore, they suggest us to use indexes rather than doing scanning when you query the data. Therefore, we need to have a local secondary index or global secondary index. I'll show you where global secondary indexes are used. Here you can see now I have put a secondary partition key in username, right? Let's think you want articles by username, which is sorted by timestamps, right? Then you need to create a secondary partition key for username, because now you don't need data from article ID. You want it from username itself. Therefore, you have to put a secondary partition key here. And secondary sort key will be timestamp. Then you will create a local secondary key. This will happen, that is, this will be global secondary key, because the secondary partition key is not equal to primary partition key. That means in here there is a critical concept here. When you use a primary partition key as the main key for a secondary index, you can use it as a global secondary index or local secondary index. That means you can decide it when you use the primary partition key as the partition key for secondary index. If you are not using a primary partition key as your main partition key for secondary index, then you will not be able to create a local secondary index. It needs to be a global secondary index, and it will create another table for you, another view. And here it says partition key can be different from the primary key, and can create at any time. That means because it will create another partition, you don't have to worry about. That means when you're creating the data set, but this will be a costly option. Therefore, it's better to know what are the keys, secondary keys you are going to have when you create the table. And this will only perform eventually consistent reads. That means you will not be able to put strong consistency in global secondary indexes, even though you have enabled the strong consistency for your database. For global secondary index partitions, it will not be valid. Right, now let's do a simple demo and see how to configure DynamoDB database. When you go to DynamoDB, you will get create tables, and there will be tables. I have created some tables. When you start to create tables, you will have to give the table name. I will give article as the name, and for partition key I will give article ID. This will be the primary key. I will give the article ID, and I will add a sort key. First I will not add a sort key, and I will show what will be the error I will get when I create the secondary keys. Here you can go to default settings also, but that means default settings will not have secondary indexes, and other details are there. And when you add the secondary index, again you can select what's the partition key for this. I want to create a local secondary index, therefore I will select article ID, and I need a sort key, therefore I will add category or user. I want to sort these articles by user. And now when I try to create a local secondary index, now it will enable the local secondary index. I'll show that what will happen when I remove this. It will remove that local secondary index option, right? When I make it the primary key name, it gives this option, and I'll create the local secondary index. Now I'll try to create the table and see what will happen. It will not allow me to do it because now I am using a local secondary index. Therefore, I have to put a sort key for here. I'll put category here, article ID, category, user ID, username, timestamp. Right. For now, what I will do is I will create article ID and category. I will use as the primary key. And now I have created a local secondary index using article ID and user. I will add another global index. So, and timestamp. Normally when you add timestamps, it can be numbers, but I'll put the string here for Now you don't have that local secondary index option. Now it has to be a global secondary index. And even you can select, that means what are the keys. That means if you want to have keys only index, it can be done, and we can include the columns, any column you want to create in this view or the new partition. I'll put all and I'll add the index. Here you can see now for this global secondary index, they are creating a new table and it has read-write capacities, and based on this you can see the estimated cost can be changed. The monthly it's $6.58. Using capacity calculator you will be able to see get what's the capacity you want to put here, and you will be able to change it accordingly. And I'll create the table. Now you can see you will not be able to see anything other than the primary partition key and sort key. When you go to items, again it will be article ID and category, and indexes you can see what are the indexes you have put, the local secondary index and global secondary index. You can see here it says it's active because it has been created as another partition. And now I will add data to this. Now let's try to add only article ID and see whether it will work. No, it's not working because we need to put category, then we can check whether it will work or not. It says now we have to put other data also. I'll put something like this, and to get the timestamp I'll go to now you can see we have data. When you query or scan data, that means you have two options to read the data. First one is query, and second one is first one is scan, the second one is query. Scan is costly. You can use query anytime you want. I will create some items. And items also you can create using, that means text option or tree option. Here you can see when it comes to text option, this is how DynamoDB is saving your data. That means this is the ID, that means column ID, and this is the data type. If it's string, it's S. Likewise, and this is the data you are going to put. This is how database is saving the data set. And now if you want to query it, you will be able to select a key from here, that means indexes, and the primary key is available. You will be able to select something like that, search, then it will be you will be able to query it. Now I'll show you how to access this using Lambda. I have created 3 Lambda services here. First one, you'll see what is this, and here I have article ID. I want to make sure the IDs are correct. Category timestamp and user category. category, timestamp, and usage there. And I have additional data also here. But let's see what's going to happen when we run it. Now it's successful, and let's go to database and see. Oh, sorry, I have to change the data table name because I have put a new table. I have to change the data table name into article. Now let's save and test it. It's done, and let's scan. Now you can see that's there. Likewise, that means I will explain this a little bit, how to access DynamoDB, but I will not going too deep. Here you can see you are getting a AWS SDK, and in SDK itself you have DynamoDB document client, and you use it to put your data, and you can set parameters like this and call that option. Now let's change it to right. Now let's call it through the API gateway. Right, I have created the services here. Here you can see the put service. It is connected to Save Data Lambda. Save Data Lambda is here. It's saving data into DynamoDB table. Right. Now I will test it. It's looking fine. And when you scan it again, you can see the value is here. Right. Now the same way I have created scan DB function. It will scan the DB. It has to be article. Let's test it. It's working fine, and it gives the output with count and scanned count, because this can be differ, because you can scan this for specific article ID, right? Then it will give, that means let's think the result is one article, then count will be 1, and scanned count will be the number of articles you have in the database, unless it overflows the maximum amount which can be scanned. That's there, and here you can see how much documents we have scanned to get the result. And this is also configured to this, and you can test it through that. Oh, I think this is connected. Okay, this is the same API. You can see the same output. Likewise, when you want to read data, you have to use the get document client get option, and you will be able to set up the key and get the data out of it. I'll quickly go through it and see whether user is Amith and article ID is 1. It's there. We will test it. it will provide the value. So go to API gateway and test it. It will provide the value, same value. That means now you can see how API gateway to Lambda to DynamoDB, everything is connected. And I'll do another session about now you have configured everything in AWS console, right? But this is not the correct way to do it. Therefore, you need to. That means I'll teach you how to do it in coding and using serverless framework. How to put it to this AWS services. That means it will be automatically implement in AWS. And I will do another session to show you how to configure Lambda API gateway and DynamoDB using code only. That means it will be your IDE and you will code it, and you will use serverless framework to configure everything in here without using the console. That's for today, and I hope you have learned something out of it. And yeah.
Yes, Amith. So thank you, Amith, for all 3 sessions. Much appreciated. So if you all have any questions, you all can ask. Okay, all right. Then I hope you all understood and found it interesting. So we will be having the next Tech Talk session on the 7th of August by Rajita. The flyer will be circulated soon. So highly appreciate your participation. Thank you everyone for taking part in today's session. Have a nice day.